Hey guys, welcome to another episode of MSK Coding. This is about the math walk, subtracting reverses. We choose a two-digit number, find the reverse, subtract the smaller from the larger, and continue. What do you notice? What do you wonder? Let's look at my code. You got a little sneak peek of it at the start of the video, but let's see. Define MW of X, and I'm not going to talk about the code for now, because I'm going to explain that later. MW is short for math walk, a mathwalks if you have a question about that. So let's use the example 36. It outputs 27, 45, and 9, just like we have on the right side of the equation in the mathwalk post. So at least we know that for 36, it works. So now let's get to my slideshow. Here, mathwalk, subtracting, reverses. Let me do a pointer. Yeah, that'll be cool. What am I doing? This is a slideshow all about the math walk, subtracting reverses. I will show you what I have noticed so far about the math walk because it does say, what do you notice? What do you wonder? What I have noticed, part 1. My goal here is to show you the introduction that you need for the later part of the slideshow. Let n be 10x plus y, where x and y are digits in the two-digit number xy. Let's look at the equation. N plus 9 equals 10x plus y plus 9, which is 10x plus 10 plus y minus 1, which is the same thing as 10 times x plus 1 plus y minus 1. Here you see that when we add 9 to a number, we add 1 to the digit in the tens place and subtract 1 from the digit in the ones place. We can generalize this equation to n plus 9a equals 10 times x plus a plus y minus a. Now we can see that when we add 9a to some number, a is added to the tens digit, and a is subtracted from the ones digit. What I have noticed, part 2, part 1. This part is the body of what I have noticed, so I'll have to split this part into two parts. One part of the math walk is reversing the number you input, while the other is subtracting. I will be talking about the reversing now. I have a process to reverse numbers, and this is it. X plus y minus x and y minus y minus x. Let's use 47 as an example here. 4 is x and 7 is y. 4 plus 7 minus 4 is 4 plus 3, which is 7. 7 minus 7 minus 4 is the same thing as 7 minus 3, which is 4. Combine those and you get 74. So the idea here is that x plus y minus x gets converted into the new x, and y minus x equals converted into the new y. If you found anything familiar in the process, I will explain it in part 2 of part 2. If you haven't, I'll explain it to you. What could be familiar about the process? Well, there's x plus y minus x and y minus x. These statements can be shortened to x plus a and y minus a, where a is y minus x. You might remember x plus a and y minus a from part 1, where we add 9a to n. Well, now we can combine both y minus x and x plus a and y minus a to create another process for reversing. This process is n plus 9 times y minus x. It's really short, so you can reverse numbers easily. So maybe let's use the 36 that was in the math walk problem. So 36 plus 9 times 1 minus x. 1 minus x would be 6 minus 3, which is 3. 3 times 9 is 27. 36 plus 27 equals 63. So it works there. Now let's go on to the subtracting part. What I have noticed, part 3. Now we subtract. This seems like a useless slide because, well, subtracting is easy, but I found something interesting. When you subtract b from a and b is smaller than a, it is the same thing as absolute of b minus a and absolute of a minus b. So we can just do absolute of n plus 9 times y minus x minus n, which is the same thing as absolute of 9 times y minus x, which is a multiple of 9. There's another way to prove that subtracting the reverse from the original ends with the multiple of 9. So we can start with 10x plus y, which is the original, minus 10y plus x, which is just another way of showing the reverse of the original. But that is the same thing as 10x plus y minus 10y minus x equals 10x minus 9y minus x, which is 9x minus 9y, which is 9 times x minus y. That's a multiple of 9. Since 9 times x minus y doesn't account for the times when x is less than y, we have to change it to absolute of x minus y, which is the same thing as y minus x. What I mean by times when x is less than y is because when x is less than y, like 36, 3 minus 6 is a negative number, but you can't have negative numbers as your answer, as the output, because you subtract the smaller from the larger, so you just use the absolute function. Extra, well, you always end up with 9 or 0. So far, I have only been explaining doing the process once, while in the math walk there are 3 rounds, because you go from 36 all the way to 27, which gets you to 45, which gets you to 9. So I will explain to you why you always end up at 9 or 0. Let's look at the edge case 0. Not many numbers and end up at that. This only happens when you input a multiple of 11, which is a number that has both digits the same number, like 11, 22, 33, 44, all the way to 99. This is because 0 is the only number to have the property 9 times n equals n, which makes the output always 0. With 9, there is a chain going down to 9. It's 90 to 81 to 63 to 27 to 45 to 9, and 9 goes back to 81 and loops. You might have noticed that some multiples of 9 are missing, like 36. In that case, you match the number in with this reverse. So if you put in 36, you can see that's already a multiple of 9. So you can just input 36 into there, and you follow the chain. 27, 45, down to 9. So that is it for this MSK coding video. Or maybe I can finally explain the function here. Well, it just makes a list which has the digits of the number in it in integer form. Then it just does 9 times x list of 0, or the 10th digit minus the 1st digit, takes 9 times that, and takes the absolute of that, which is the exact same thing as saying what we had back in the other slides, which was right here. 9 times absolute of x minus y. So here. Then we just print x, then we see if it's 9 or it's 1 digit, or it's 0 set to false. You don't need you only need it's not 0, length is 1, but instead the others just in case. Well, and then we just set a to false, which just closes up the while loop that we started at the start while a is true. So this goes forever until it's either 9 or 0. And then we can just run the function. Well, that is it. I'll probably upload some more videos over the months, maybe over the weeks. But yeah, bye everybody.